Very good morning to everyone. In this lecture, EC8652 Wireless Communication, Department of ECE. Today, we are talk about the topic capacity in fading and non-fading channels. So, capacity means the channel. It can be used for the single or multiple user scenario. So this is one of the topic of multi-antenna techniques. First, we focus on the characterization of user capacity. So the user capacity, it can be divided into the transmitter has instantaneous information and transmitter has statistical information and transmitter without information. So the capacity in the fading and non-fading of wireless channels. First, we can analyze of the capacity limit of the fading channels in necessary in wireless communication. It is better to focus on capacity of single user fading channel with it fade level is being tracked by transceiver system and also only at the receiver end. In case the lower complexities is observed for the independent and identically distributed fading which has receiver and end information. In complexity in the coding will increase while the capacity decreases, it correlated fading is not adapted at the transmitter in the system. Considering this that the channel is estimated at the receiver end and adaptation schemes required a feedback path between the transceiver. Now we can move to the channel and system model in flat feeding channels. It considering this channel estimation in the receiver or transmitter in the discrete time channels and in the system model, the input message transmit to the 1 to m messages. This message is encoded into the code word and transmitted over the time varying radio channels in the particular time period. The channel gain would change over the transmission of code word. This gain is known to transceiver, that is a receiver point. It would also transmit to adapt the code word to the gain and time instant. It is a more suitable for slow varying wireless channels. Let us assume that the transmitter and the receiver aware from the channel power gain. So here the capacity C of time varying channels was first considered to assuming the stationary and erratic process that represent the channel state. In this state, it take value of finite set of memory less discrete channels. Now we considered that the capacity of the channel with the probability and the channel assumed to be a state. Now the capacity of the time varying channels would be C is equal to summation of S side to S and CS into the power of the channels. It in simple model the input M, that is the input signal M, is applied to product and added through the encoder unit and power control unit. The coded signal is sent to decode and channel estimator unit. So the received signal, how we can estimate the received signal in Y of I is equal to M equal to root of Gi, that's a gain of the signal, into M plus I of N, that's a noise signals. This system model is discrete time channel with gain and also the additive weight Gaussian noise is equal to n of I. The channel power gained as said before, the gain of the input channels it expected value of the unity. So the average received signal to noise as Cy, the Cy is equal to B into log of 1 plus gamma. The capacity of feeding channels with the transceiver state information. If the transmitted power varies the received signal with respect to the average power constraints. Now we are moving to channel and system models. If the block feeding channels, that is a G of I, is constant over some block length T, after with the time of G of I changes to a independent value based on the distributions. Let us the equations, the P denote the average transmitter signal power and N naught denoted as a noise spectral density of Ni, B is denoted as received signal bandwidth. So this is a equations of instantaneous received signal to noise ratio, that is a gamma of I equal to P into G of I divided by N naught B in the interval of 0 to infinity. It is a expected value over all time is a gamma function. Now we are moving to capacity of flat feeding channels in three different scenarios. First one is channel distribution information. The distribution of informations is known to the transmitter and also the receiver side. And also the second one is a receiver channel state information. The value of the gain of the input signal, it is known to receiver at a time and both the transmitter and also the receiver distributions. The third one is a transmitter and receiver. The value of G of I is known at the transmitter and the receiver at the time I, and both the transmitter and the receiver known the distribution of the G of I. Now we are moving to the time varying capacitance or time varying capacity in the feeding and non-feeding channels. Now we are going to discuss the time varying capacity. The channel's capacity C vary with the channel state. The capacity of the feeding channels is summation of the capacities in each feed state weighted by the probability value of the state. So the time diversity system with multiplexed input and demultiplexed output. The range of the feeding values are first quantized to a finite set of time period. If a block length is a n number of block length, the encoder has to average power that attend the data rate of the signal. So the gamma on y naught and y1 to yn is encoded input signal to encode the different signal of the time period. The optimal power allocation is say a water puring and water filling scheme. They need to feedback between the receiver with the cost of the complexity at the transmitter side. These techniques provide the highest capacity in the system encoder in the transmitter and the receiver. So we can focus the coding and decoding in the non-adaptive technique. If the gain is known at the receiver side by scaling the feeding channels with the proper power gain. The proper power gain is one of the independent and the identical distribution of the faded signal. Then the independent distributions, the Gaussian distribution at a time I with the power signal. Thus the capacity with the fading, that is a fading and non-fading, with the receiver side information is expressed in terms of log of 1 plus y into p of y into dy. This difference between the curve observed and also the time with a different coefficient factor. Now we can move to the optional power allocations. To find the optional power allocations S of v, we form the Lagrangian j of p of y is equal to gamma is equal to integral of 0 to infinity b into log to 1 plus gamma p of gamma plus p power into p of y dy minus lambda into the integral 0 to infinity p of y dy. So these conditions, it can be the optimal allocation in the transmitter and also receiver to estimate the symbol of duration in each individual received signals, that is different time periods. So we can find out the additive white Gaussian noise channel information and also the average signal to noise ratio in the capacity in the log normal functions. Now we are moving to the zero outage capacity and channel inversions. In this region, the zero outage capacity means that it one of the fading inverted to maintain the constant signal to noise ratio, and it designed the fixed rate of the error signals, and it sends the data rate is fixed under the all channel conditions and there is no channel outages. And the channel inversions, it can be applied implemented to the session, the suboptimal transmitter adaptation scheme where the transmitter use the state information to maintain the constant received power level. So power level, it can be adapted to individual received time periodical signal. This power adaptation, it called a channel inversion. So it is given the equation of P of y divided by P is equal to sigma divided by gamma. It is a equal constant received signal to noise ratio that can be maintained with the transmitted power. Now we can move to the outage capacity and truncated channel inversion. The outage capacity is defined as the maximum data rate that can be maintained by suspending transmission in bad feeding status. Once we can maintain a higher constant data rate in other state and can increase the channel capacity, the outage capacity is achieved with truncated the inversion policy of the power adaptation. So this compensation of feeding above the certain cutoff feed depends on depth, where the y of 0 is based on the p of y divided by p into the condition of gamma greater than or equal to gamma naught. So the outage probability of these conditions, the channel is only used for the received signal and also the errored message state information of the original signal. Thank you for watching this video.